Okay, so this is I just want to take just a few minutes. This really short one. I just wanted to introduce the construct that I'll be using in the garage case examples when we start introducing uncertainty into our model. Right? There's a tool that we use called Varg curve. It's value at risk or gain, and it's really a great tool to enrich the decision making. So I'm gonna go through that quickly. Um, so if we introduce uncertainties, one natural one, certainly for the garage case, is to introduce some variation in demand, right, based on historical data. And the design levers that I might have are to build all at once, do a planned stage construction, shut down, right? We could do that too. That would certainly be an option. Okay? So an example of a planned stage construction. So I could make some conditional rules in my model that say, if the demand growth in the previous 2 years grows more than some number, I'll add a floor. Otherwise, I won't do that. But the demand will be a variable. It won't be. It'll follow the model that we used before, but there's some variation each year. So you never know. So we build that into the model. So these Varg curves give a much richer picture of the net present value numbers. So introducing variabilities in the demand, the input variable introduces this as a random variable now. The net present value becomes a random variable. And the Varg curve is basically just the cumulative distribution of that random variable. This stands, as I said, for value at risk or gain. For our purposes, it's the cumulative frequency distribution of this random variable. Okay, so we'll introduce the variation, generate a set of random numbers, and then use the Monte Carlo method. I'll show you how I do that in the next videos when you start looking at the examples, the garage case examples. You'll see how that was done, and then plot them on just a graph. So I've got an example here that I'll show you. It's a much simpler example than the garage case. From problem 11.1, we were given three alternatives. We had to evaluate them. What if we introduce, and I'll only use one of the alternatives because I'm lazy. I didn't want to have to do more than one. If I introduce some variation to, say, the yearly benefits on average, so there's, say, on average, the average value was 600, and that's the one we used. But what if there was we could observe in historical data that there's a plus or minus 25% variation in that number? So here is the setup. Once again, the cost, $2,000. You can go back to problem 13.3 and see this. Now I've introduced this savings. This is a cell reference to this base savings, introducing this random variation of 25% plus or minus. Using the built-in RAND function in Excel, you can do this. No salvage value, discount rate, life don't change. The net present value then becomes a random variable because of this savings number, right? So if I generate say 100, I generated 100 well, actually, I generated 100 observations of net present value using the technique that I showed, using Monte Carlo, the technique that I showed you in the following videos. You'll see how to do this. Don't worry about how to do this yet. You'll see it when you watch those videos. But this is the output. It's basically, like I said, just a cumulative frequency distribution. So I know, for example, that 50% of net present values that could result from this project will be less than 350 or so, right? Only 40% will be less than 200. So that's, that's good information to have. It's really valuable if you're comparing alternatives. You can take a look at this. This is actually from the garage case. Later on, you'll see this curve again, but this is the base case when we just built the thing, six levels. This is that flexible stage construction that I mentioned. This is the Varg curve for these two. Look how much nicer. So there's a 40% chance that the median, or the 50% chance, right? This is the median value way up here, much higher than this one is, and you can see kind of the distribution of in all cases you're going to be better off. Okay. So the expected net present value here is minus 3.65 million. Here it's 20.5 million minus, right? So that's the 50% mark. The 10th percentile for this curve, it's minus 25. The 90th percentile is minus 16. So that's a pretty, I'm 90% sure I'll get at least this much. No, I'm not. 10% sure I'll get at least this much. I'm 90% sure that all the values would be less than this. So this is a hard number to hit. This one, on the other hand, I'm sure that at least 90% will be greater than this number, and so anyway.